Hello everyone, my name is Karolina. I work at Nuaware. We specialize in helping organizations choose the tools, partners, and skill sets needed for a successful adoption of enterprise-grade technology. Today, I'll introduce you to the concept of CI/CD, short for continuous integration and continuous delivery. I'll walk you through the topics of CI/CD basics, automation from a technology and business point of view, what modern CI/CD looks like, and how all of that gives a basis to the newly coined concept of DevSecOps. Now, a CI/CD pipeline helps you automate steps in your software delivery process, such as initiating code builds, running automated tests, and deploying to a staging or production environment. Automated pipelines remove manual errors, provide standardized development feedback loops, and enable fast product iterations. An enterprise can build their own pipeline in-house or with an assembly of tools available on the market. They can also opt in for a more end-to-end solution, such as a software delivery automation platform by Cloudbees. A typical CI/CD pipeline will involve building code, testing, and then merging it from all the different sources/developers involved in the project. The goal is then to introduce automatic deployment to repositories. And once that's achieved, the final step is for the code to be automatically deployed to production. Now, before we talk about CI/CD in greater detail, I feel it's necessary to take a step back and look at automation as a whole. VMware refers to IT automation as the process of creating software and systems to replace repeatable processes and reduce manual intervention. Now, business process automation, on the other hand, is a way of using software to make business processes happen in a manner that's seamless and effortless. Now, the benefits of that include the increase of productivity by reducing the time taken to perform repetitive tasks. Increased productivity with less labor costs and defects means increased profit as well. Cost savings are also made by the reduction of training that staff will require. Historically, it could have taken a long time to train staff to do even the most repetitive of tasks. Automated systems also make auditing an easier process in itself. This also means that they will always ensure compliance with internal and external requirements. Automation also allows for flexibility, making it easy to make changes, or at least far easier than it would be to change processes that involve only humans. And the fact that defects are reduced means that customer satisfaction is increased, often quite significantly, so customers will be kept happy whilst profits are increased. And when we look at the technological benefits on the right-hand side, we can see that automation allows for quickly rebuilding development environments. Now, one of the biggest problems with projects with bad automation is the constant discrepancies between how the software works and runs in production compared to development and testing environments. Due to the fact that changes between environments need to be replicated by hand, it's either done rarely or not at all. Each and every environment has some specific quirks, and if there are many of them, this problem just gets exacerbated further. Automated quick environment rebuilds eliminate this problem altogether. There's also only one source of truth about the current state of the project, and that's the build. Building the software gives you a true image of what the code looks like and how it works. The assessment of the results is clear, and there are no issues like it worked on my computer or it works in dev but it doesn't run in the test. Automated processes will also reduce defects, which in turn enhances production speed. And automation will also ensure that each process will run effortlessly and that it will run the same way every time. Now, continuous testing means that you can build software and test its deployment in the testing environment until you get the desired effect and a guarantee that the deployment will go exactly as predicted. Now that I hope the concept of automation of software delivery processes is clearer, I'll dive into the concept of CI/CD in great detail. In traditional software development, the process of integration generally took place at the end of the project after each person had completed their work. Integration generally took weeks or months and could be very painful. Continuous integration is a practice that puts the integration phase earlier in the development cycle so that building, testing, and integrating code happens on a more regular basis. Continuous integration means that one developer who writes code on his laptop at home and another developer who codes on her desktop in the office can both write software for the same product separately, integrate their changes together in a place called the source repository, such as GitHub and Sonatype, and then the developers can build the combined software from the bits they each wrote and test that it works the way they expect. Continuous delivery means that each time a developer makes changes to the code, as explained above, integrates and builds the code, they also automatically test this code on environments that are very similar to production. We call this progression of deploying to and testing on different environments a deployment pipeline. Often the deployment pipeline has a development environment, a test environment, and a staging environment. But these stages vary by the team, product, and organization. And continuous deployment is a practice where every change that a developer makes and which passes all the test stages automatically goes into production. Some companies do this step and others do not. To achieve continuous deployment, you first need to get to continuous delivery. Now let's move on to how next generation CI/CD pipeline powered by Kubernetes looks like. As a bit of background, after virtualization, we've entered the area of containerization, where we break down applications into microservices, injecting a high level of automation and complexity into our IT infrastructure. Before I explain how to navigate building and maintaining a CI/CD pipeline in this environment, I have a brief recap of the key concepts involved. Kubernetes is an open source container orchestration system. It's used for automating application deployment, scaling, and management. Running your apps in containers ensures that they have all the resources and libraries they need. This makes your app portable between environments, easy to replicate, and scalable. Now, once your apps are running in containers, they still need to be managed. Someone has to deploy them, monitor their health, and scale them to meet demand. You could do that manually, or you can let Kubernetes orchestrate all of this work for you. Yet again, adding another level of automation. Now, the key to a successful CI/CD pipeline is to ensure that your application updates occur in a swift and automated manner. Kubernetes offers plenty of solutions for common problems that programmers face throughout this process. Here are some of them. Many programmers struggle when they stick to a manual testing and deployment process. Doing so can cause delays, which push back your production timeline. A manual CI/CD process leads to more code merge collisions, as well as the time that customers have to wait for patches and updates. A manual infrastructure management process also causes headaches for coding teams because someone has to remain alert in case any outages happen. A number of issues can arise, such as a power outage or an unforeseen traffic spike beyond capacity. This requires someone to be alert around the clock to solve these issues. If your app is down, you will lose money and customers. With an automated platform such as Kubernetes, you can automate those patches and updates and solve those outages quicker. If your apps are not packed efficiently into servers, you may be overpaying for capacity. This is true regardless of whether you're running your application in the cloud or on-premise. Kubernetes maximizes the efficiency of your server usage to ensure you're not overdoing it or underdoing it. And with the platform, you can run your apps in containers. This ensures they have the resources and libraries necessary, while also preventing common issues that arise between library version and application components. Containerizing the code makes your app portable between environments, while also making them easy to replicate and scale. And Kubernetes makes the deployment process easier in a number of ways. Running apps on containers doesn't solve every problem in the CI/CD pipeline, as you still need to manage these apps. The platform can do everything from deploying them to monitoring their health and scaling them to meet customer demand. Second most important indicator of a mature software delivery pipeline is the integration of security from the get-go. Traditional IT structure is siloed with poor to no collaboration between the development, operations, and security teams, frequently resulting in a faulty or not secure product being released into the market. Now that we've walked through how to empower our DevOps culture with a strong CI/CD pipeline, ideally supported by Kubernetes, I'll explain how to further mature it by adding security features at every step. First, enterprises ought to integrate security scanners for containers. This should be part of the process for adding containers to the registry. Then we automate security testing in the CI process. This includes running security static analysis tools as part of builds, as well as scanning any pre-built container images for known security vulnerabilities as they are pulled into the build pipeline. We should also add automated tests for security capabilities into the acceptance test process. Automate the input validation tests as well as verification, authentication, and authorization features. Next step would be to automate security updates such as patches for known vulnerabilities. Do this via the DevOps pipeline. It should eliminate the need for admins to log into production systems while creating a documented and traceable changelog. Last but not least, we automate system and service configuration management capabilities. This allows for compliance with security policies and the elimination of manual errors. Audit and remediation should be automated as well. And for my final slide, I wanted to touch upon a very hot topic in the world of modern IT, and that's DevSecOps. I've briefly explained how it can be done from a point of security automation, but it's also very important to know why. It's not possible to overemphasize the need for security in a world where breaches and vulnerabilities continue to cause massive reputation and financial losses to businesses of all sizes and capabilities. Since the CI/CD system offers access to your code base and credentials to deploy in various environments, it's often the prime target. Recall the infamous Uber breach where hackers gained access to AWS credentials that were embedded in the GitHub repo, stealing the personal information of 57 million users and 600,000 drivers. It's certainly not uncommon for credentials to be stored in private repositories for automation purposes. Therefore, you should consider isolating your CI/CD systems, placing them in secure internal networks. VPN, strong two-factor authentication, and IAM systems will help you enforce the principle of least privilege and restrict exposure to threats. For example, containerize your agents and place them on secure networks. In addition, you should also ensure that security is baked into the development process from start to finish. And all of that is commonly known as DevSecOps. Thank you so much for listening in. I hope this presentation helped you to understand what a CI/CD pipeline looks like and how it's evolved in the past couple of years.